In this video, I'm going to take a little time and show you how we solve several gas laws. These are all based on the combined gas law, and we can have references to Boyle's law, Charles's law, Gay-Lussac's law, and Avogadro's law. I'm not going to include Avogadro's law here. I'm only going to include Boyle's, Charles, Gay-Lussac's, and the combined gas law. First, here is the combined gas law. It's P1V1, where P stands for pressure, V stands for volume, and T stands for Kelvin temperature. This is of critical importance. Never use Celsius temperature in a gas law problem. Now, let's consider, I'm going to use a green here. If I hold temperature constant, if T is constant, we can cross out these T's and we end up with Boyle's law, which will be P1V1 equals P2V2. And I'll talk more about that in an upcoming slide. If we hold pressure constant, we end up with Charles's law. And that would be V1 over V2, or excuse me, T2 equals V2 over T2. Again, I will talk about that more and solve a problem or two. And finally, if we hold V constant, what did I just erase there? If V is constant, we end up with Gay-Lussac's law, which is P1 over V1 equals P2 over V2. Now let me move on to the next slide here. And we'll talk about Boyle's law. Boyle's law is P1 V1 equals P2 V2. In this problem, we can say that pressure and volume are inversely related. In other words, if P increases, V will decrease. That's what an inverse relationship is. Let's take an example problem here. We are given the following information. 2 liters of gas, 2.00 liters of gas is at 740 millimeters of mercury. Find volume at standard pressure. So I like to do these problems like this. I have P1, I have V1, P2, and V2. I'm going to fill these out by identifying the variables. I have 2.00 liters and 740 millimeters mercury. My P2 says I had standard pressure, and we know that 760 millimeters mercury is standard pressure. That information can be found on your periodic table. And this is our unknown. You can either arrange, I'm going to go like this. You can either sub and solve, or you can rearrange the equation first. I'm going to do this one by just subbing and solving. So I'm going to have 740 millimeters of mercury times 2.00 liters. Notice I'm making sure to include my units in every measured value that I'm writing down, will equal 760. I'm going to go 0.0 millimeters mercury. I should have written 740 millimeters. I was given more significant figures of this. This should have been 7. Whoops. Sorry about that. There we go. Times V2. We will simply do simple algebra to do this. We're going to divide each side by 760.0 millimeters mercury. We'll be able to cross this out, and we will end up with V2 equals 1.95 liters. Make sure you can get this answer, and please note that I've been mindful to include 3 significant figures. That's how we solve Boyle's law problems. Please remember, for Boyle's law, T is constant, so we don't need to include that in the problem. Next, let's consider Charles' law. Charles' law is V1 over T1 equals V2 over T2. Please remember, T must be in Kelvin. Let's go ahead and do a problem on this one. A gas is collected and found to occupy 2.85 liters at 25 degrees Celsius. What will the volume be at standard temperature? I'm just going to abbreviate that temp. And please note that standard temp is 273 Kelvin. Again, I'm going to label all my variables with units. I always do these the same way. I'm given 2.85 liters, and this will be 25 degrees C plus 273 equals 298 Kelvin. This is 273 Kelvin, and this is unknown. For this problem, I'm going to rearrange and then solve. As I rearrange here, I'm solving for V2, so I need to multiply each side by T2. I like to have my unknown on the left, just my own personal preference. That'll be V1, T1, and T2. So now subbing, V2 will equal V1, 2.85 liters times 298 Kelvin divided by 273 Kelvin. V2 to three significant figures will equal 2.61 liters. Make sure you can do this problem. Make sure you know how to set this problem up. Next, another simple one here. Let's do Gay-Lussac's law. Gay-Lussac's law is P1 over T1 equals P2 over T2. I should have mentioned for Charles' law, this tells us that volume and temperature are directly related. That is a direct relationship. For Gay-Lussac's law, P and T are also directly related. As opposed to inversely related. Now let's go ahead and solve a problem here, and I would like to find one where we're solving for temperature. So I'm going to cheat a little bit here and just write our givens down as follows. I'll tell you what we're given, just to save a little time and energy. In our sample problem here, we're told we have 10 liters of a gas. Okay, that's going to be constant. It found to exert 97.0 kilopascals at 25 degrees Celsius, which when we add 273 will give me 298.0 Kelvin. Our next pressure is 101.325 kilopascals, and this is our unknown. So for this problem, we're going to be solving for something in the numerator, or the denominator. I'm going to highlight that quick. For this particular problem, we are looking for this value. We're solving for T2. So we have to be careful not to solve for something when it's in the denominator. We need to get it into the numerator. So I'm going to move my T2, whoops, T2 will equal, I'm going to just move this up here, and that will equal P2 T1 over P1. I need you to verify that you know how to do this. Verify you know how to rearrange. Okay, now we're going to sub and solve. T2 will equal P2, which was 101.325 kilopascals times 298.0 Kelvin divided by 97.0 kilopascals. 97, 1.3 times 298. Okay, so my T2 is going to be equal to 311.3 Kelvin. There we go. Now we're going to use the combined gas law, which puts all of these variables together. These aren't hard to solve. You just have to make sure that you're rearranging carefully, you're including your units, and that you've identified and labeled everything appropriately. I always start these by doing P1, V1, T1. You can do those in any order you want. And then in the next column, adjacent column, I put these in the same order. And if you do this, you're going to minimize your errors tremendously. As always, remember to convert your Celsius temperature to Kelvin temperature if necessary. You can use any units of volume that you want. Oh no, I have a low battery. So let's go ahead and I'm going to just pick one of these to do. I'm going to put it down here. We'll be given the following problem. 2 liters of gas at 25 degrees C and 745.0 millimeters of mercury are my initial conditions. We're asked to find the volume at STP. STP, you've got to know this. T at STP is 273 Kelvin. I'll go 273.0 to match. And P at standard pressure is 760, and I'll just match this. So we can fill these out as follows. This is my unknown. This is 273.0 Kelvin, 760.0 mmHg. This is 745 mmHg, 2.00 liters, and what was this one? 298, I believe. Yes, 298.0 Kelvin. And we got that by taking 25.0 plus 273. Now we can go ahead and sub and solve for this one. And I think this one I'm going to rearrange first. We'll be solving for V2. So V2 will equal P1 V1 T2 over T1 P2. And that means I just put this in the denominator and I put this in the numerator. I'm going to erase that because that's too busy for me to stand. Now we're going to sub and solve. P1, we're going to have 745.0 mmHg. Students who are good at this, do not leave the units off. Times 2.00 liters times 273.0 Kelvin divided by 760.0 millimeters mercury times 298.0 Kelvin. Check the math on this one, and you're going to get V2 will be equal to 1.796 liters, and we must report this to 3 significant figures. We will get 1.80 liters. Be careful if you're solving for P1 V1 over T1. If you're solving for a T2 here, be careful not to solve for 1 over T2. If we're solving for this variable, you need to move it to the numerator. So T2 will equal P2 V2 T1 over P1 V1. And if you need to watch how that's solved, let me do it down here. If you know how I did this, no need to watch that next part. Again, we're solving for T2. So let's go with blue here. I'm going to multiply each side by T2. Then this will cross off. Then I'm going to divide by P1 V1, divide by P1 V1, multiply by T1, multiply by T1. Cross, 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 cross. I get my 2 equals, as I listed above. Simple algebra. Just very simple algebra. Hope this helps. The best way to get good at this is to practice and then practice some more. Done.